There we go. So these are our three formulas. We can rearrange those to give us any of these as the subject. Now, let's try a practice problem. So, tennis ball. Look at that beautiful drawing. It's thrown up into the air with an initial velocity of 8 meters per second. How long until it reaches its peak position? Ooh, that's a funky parabola. Here, what will the distance be? There, and how much time will it take? That there is what we are solving for. So, we know our initial is 8. We know acceleration is negative because it's acting against the 8 meters per second. 9.8. Our ending velocity is going to be where it stops and starts to come back down. So our ending velocity is 0 because there'll be a singular moment where the ball stops right before it turns around and comes back down. So why don't we rearrange this equation here to make t the subject? So v equals u plus at. So now we're going to subtract at, so v minus at. Now we're going to add, minus v. So we're going to get negative at equals u minus v. And now we are going to divide, because we want to make t the subject, by negative a. So we're going to get t is equal to u minus v on negative a. Okay, so let's substitute in u minus v, so 8 minus 0 on negative of negative 9.8. Which will just be 8 on 9.8. If we put that into our calculator, t is going to give us 0.8163. So we're just going to round that to 2 decimal places. So 0.82. There we go. So we have our time, 0.82 seconds. Now let's find our displacement at the top. So S is equal to, we don't even need to do any rearranging. S is equal to, we're going to use this one here. We'll just put the numbers straight in. So UT, so 8 times 0.82. 8 times 0.82 plus half a times t squared. So negative 9.8 times negative 9.8 times t squared, 0.82 squared. we put that into our calculator, that is going to be equal to 3.265. 3.2 oh, 265 or 3.27. 3.27. Okay. 3.27. Don't forget our units, meters. So, there we go. We have got a SUVAT which solves for a ball problem like this, and got everything we need to know. Now, if you want to pause the video, how long will it take for the ball to go up and all the way back down? So, we could do the exact same SUVAT and solve for time, or we actually know that the time up will equal the time down. Time up equals time down. And that's because the ball was thrown at the same point that it will land. It'll land at the same height as where it was thrown from. If the ball was thrown from a high platform and thrown like that, it wouldn't. Or if it was thrown up somewhere, it wouldn't. It's only if it's landing at the same spot that's taking off, then T up will equal T down. So, to find total time, .64, or 2 times that number there. So, let's wrap this up. We've got our SUVATs done. Now you can solve for any of these. It's just a matter of rearranging the equation so that you solve for it, and yeah, that's pretty much it. Consider subscribing.